Magandang araw mga kainhinyerong sibil. Ako ang inyong guro Daryl J. Mendros Balbin. In this video, I will solve the third sample problem in pipe connections and reservoirs. Two tanks A and B have 70-meter difference in water levels and are connected by a pipe 0.25 meter in diameter and 6 kilometer long with 0.002 friction coefficient. The pipe is tapped at its midpoint to leak out 0.04 cubic meter per second flow rate. Minor losses are ignored. A. Determine the discharge leaving tank A, and B. Find the discharge entering tank B. Since both are open reservoirs, pressures and velocities at both points are zero. Head loss due to friction is equal to the head loss due to elevation. Pipe 1 is in series with pipe 2. Therefore, we can say that the head loss in pipe 1 plus the head loss in pipe 2 is equal to the total frictional head loss. And the total frictional head loss HF is equal to the head loss due to elevation equal to 70 meters. Since we were given frictional factor F in the problem, we will be using Darcy-Weisbach formula. That is 0.826 FL1 Q1 squared over D1 raised to 5 plus 0.826 FL2 Q2 squared over D2 raised to 5 is equal to 70 meters. Substituting the values from the problem, F is given as 0.002. L1 and L2 are both equal to 3,000 meters, which we got from dividing 6,000 meters by 2. Q1 and Q2 are both unknown. D1 and D2 are both equal to 0.25 meter. From the system of pipes, pipe 1 branches into pipe 2 and pipe 3. Therefore, we can say that Q1 is equal to Q2 plus Q3. But Q3 is given in the problem as 0.04 cubic meter per second. Therefore, we have Q1 in terms of Q2. And going back to the head loss equation, we can substitute this value of Q1 in terms of Q2 into the head loss equation. So we have Q1 is now substituted with Q2 plus 0.04. Now we can see that in this equation, there is only one unknown, which is Q2. Therefore, we can solve for Q2. And Q2 is equal to 0.242 cubic meter per second, which is the discharge entering tank B. And for Q1, that is equal to 0.242 plus 0.04. Q1 is equal to 0.282 cubic meter per second, which is the discharge leaving tank A.